I'm Bob at I Like to Make Stuff. Today we're going to talk compressors and run a whole system for air tools. Today we are back at the farm, but instead of working on the car, we're actually going to work on the farm itself. We're going to work on the barn and add a pneumatic air system to this location. In my wood shop, I don't really have a whole air system set up. I have a compressor and I use it for just a couple of tools. But out here working on the car, I have a bunch of air tools. So I need an air system that can support those tools. In a wood shop, a lot of the tools that you might have that would be pneumatic are like brad nailers, pin nailers, things like that, that just have little bursts of air. They don't have to have continuous air usage, and because of that, you don't really need much of a compressor. A small pancake compressor usually is perfectly fine and it's easy to move around. But out here, the tools are a little bit different. In this case, I'm using a sander. This is called a DA or dual action sander, and something like this needs constant air to drive the sander to be spinning for a really long period of time. And there's other tools that have the same needs, like die grinders, ratchets, wrenches, all sorts of stuff that just needs continuous air to do its job. So you have tools like this that do need a lot of air, but they have on and off switches. They can work in small bursts if you need to, and you can wait for the compressor to refill. And then you have things like sandblasters and paint guns. You can use those and take breaks and wait for the compressor to refill if you need to, but in the case of a paint gun, that actually would give you a pretty bad finish. You need a lot of air behind those things to have a really consistent usage of the tool. So as far as compressors, this is what I would call a pancake compressor. It's pretty small, it can't put out a whole lot of air, it can't hold a whole lot of air, but this is a fantastic way to get started, especially if you're using things like brad nailers and pin nailers. This is a great option. The cool thing about this is that it will plug into absolutely any outlet. It doesn't have a big power requirement. It's light enough that you can pick it up and carry it around. It's easy to empty the air out of it. Something like this is a great place to start. Over the years, I have tried to up my compressor over and over and over by getting one that's a little bit bigger and a little bit bigger to try to keep up with the tools, and it's never been enough. So I finally bit the bullet and spent a lot of money on this thing. This is what I ended up buying after a very long time, and I will be the first to admit that this thing is overkill. It's expensive, it's loud, it takes up a lot of room. This is not really the point, because what I want to do in this video today is set up a system that can take advantage of whatever compressor you want to put at the beginning of it, and then as you go along, you can always upgrade that machine to something more powerful. So if you're just running brad nailers, pin nailers, things like that, you really don't have to worry about which compressor to get. Just find one that fits in your budget and is not too loud. If you need to think about something that runs certain tools, there's a lot of things to consider about the machine itself. The capacity of the tank is one, but the motor is also very important because the motor is going to be filling up the air inside the tank. And if this can't keep up with the tool, it doesn't even matter how big the tank is. There's a couple of acronyms that you're going to see when you're looking at these that you need to understand. One is PSI. PSI is pounds per square inch. It's a measure of pressure. It's measuring how much force is put on a given area. CFM and SCFM are about volume, specifically how much volume of air can be moved over a certain time. So they're both really important numbers, but one of them may be more important to you than the other. Another thing just to keep in mind is the maximum PSI that the machine can put out. Basically, you just need to look at the needs of your specific tools and make sure that this can keep up. So just remember, as you're picking out a compressor, the size of the motor matters, the size of the tank matters, and the CFM and PSI. Keep all those things in mind, as well as the amount of noise that it creates. This thing is super loud. I would not put something like this in my house, maybe not even in my garage, without building an enclosure around it to dampen the sound. And that is definitely something you want to think about. On top of that is power. This thing runs off 230, so I actually had to wire up a separate circuit just to run this particular tool. Now if you have a small pancake or even a bigger compressor that runs off of 110, you can drag that around and plug it in wherever you want to. I've got this thing powered, it's ready to go, but that's all I've done. So next, I need to add a shutoff valve to the side to actually be able to close up the tank so it can hold pressure, but also I need to add a drain to the bottom. This is really, really important because you don't want to leave compressed air inside of a tank for a really long period of time, and that's because as you compress the air, moisture comes out of the air, settles on the bottom of the tank, and if water sits there long enough, it will eventually rust through the bottom of the tank, and a tank with a hole in it cannot hold air. So that drain is now installed, and that will blow out all the water at the bottom of the tank. But water is a big concern in air systems. You don't want water going into any of the tools, especially if you're using a paint gun. You don't want water in there. So you need to add ways to get water out of it. We're going to do more of that in the system, but the first thing that we can do is add this. Now this is going to be on the wall, mounted at the output of the tank, and this is a combination of things. We've got a regulator to regulate the pressure coming out of the tank, and a water filter. This will take out particulates, mostly water, but other things as well, oils, anything that's in the air should get caught here as a first measure of keeping it out of the rest of the system. So we're going to run a big thick hose out of the tank into the regulator, mount this thing to the wall, and then we can build out the rest of the system. I've got the regulator and the filter attached to the wall, and I went ahead and put a connector on it so that we can add our lines going out from this point. I'm going to be using a system of line that's made specifically for this, but you could build your own if you want to. There's a bunch of different options what you can use for pipe. One of the most common things that you'll see in an industrial shop is to use copper pipe for all of this. Now for me, that would be really expensive, and I don't have a lot of history sweating copper pipes, and so making all the joints would be difficult and time consuming, and so I went with something else. But if that's your bag, then go for it. Another thing you'll see is stainless, also very expensive, hard to connect, but possible. Aluminum pipe, which is a little less common, but it is an option. When you're looking around online, you may see people talk about using PVC or PEX for this. It's not really recommended. Those things are not made to hold the pressure that you might put into them. Now, it may be possible at low pressure, but it's still not a great idea. The system that I got is actually a combination of some of those things. Let me show it to you. The kit that I got is just something I found on Amazon. It's not sponsored in any way, and I got it because the reviews were good. And since then, I've had several people who've actually already installed this that reached out and said, this is the way to go. So I'm really happy to hear that. I'll put a link to it down in the description if you want to check it out. But basically, the reason that I was interested is because it's a combo pipe. This pipe has a PEX type plastic on the outside, and then an aluminum liner, and then more plastic on the inside. So it is very bendable. It is very rigid, it's not going to corrode, which is a big consideration when you're running pipe. On top of the pipe, this kit came with pretty much everything you need to make 3 outlets. So it came with some T-connectors, a flaring tool to flare it, to add it to the connectors, and it came with each one of these. This is the block where you will connect the hose connector to actually put in your hose. The line will come down and connect to here, and one of the coolest things is that it has a drain built into the bottom of it. So as condensation fills up these pipes and lands down here at the bottom, you can always open this little drain, blow out the condensation before you use the tool. This kit comes with pretty much everything you need to set it up, so let's give it a shot. This is essentially what the system is going to look like. It comes off the main air and then splits. It's going to split several more times within the shop. Each one of those is going to terminate at one of these blocks. Now I already said that there is a drain at the bottom that you can keep closed. There's a plug on the back, which I assume is in case you wanted to have this line come in from the back side. I'm not really sure. But on the front, there's a 1/2-inch hole. Now this is where the problem comes in with pneumatics. There are 4, at least, different size fittings for all of these different things. This is 3/4. This is 1/2 inch. On the bottom here, on the top of this piece, is 1/4 inch, and then there's also 3/8. So you're gonna have to end up finding all of the different pieces to fit all of these different things. Normally, one of these would go right here, but it's the wrong size. I have not been able to find a 1/2 inch converter for this anywhere locally, so I had to order them online. They'll be here in a couple of days. But once I get that piece in, it will essentially have one of these sticking out of the end of it. Now this is a common piece that you'll see on the end of some of the hoses or coming out of the end of the compressor. And this piece is what typically goes on the other end of the hose or at the end of your tool. These two things fit together. This is spring loaded so that when you pull it back, they will snap together and stay together until you pull it back again, and it will kind of force that piece out. This part is pretty standard, but the other ends are where you're gonna have to find the right sizes. So here's a couple of the quick connectors that you'll see, and basically it's the same thing with a male or female connector on each end. And then like I mentioned before, this size right here could be 1/4 inch, 1/2 inch, 3/8, 3/4. there's a bunch of different options. So now we're ready to move ahead with building out the rest of the system, and I'm going to put a straight piece that goes up here to another T. I did want to point out that these short pieces were actually pretty hard to straighten. So if you're going to do this, and what I'm going to try next is to straighten large sections and then cut them down to smaller pieces. This is called the stand-and squish. And this is called the push and flat. That actually works pretty well. Stop. This is how you measure a curve, kids. It's not really, but it doesn't have to be exact. So right there. Ow!
So you make lightsabers.
I realized that there's actually a cool little thing on this tool that I didn't realize was there at first. There's a small cutter down on each side of this piece so that when you push the pipe all the way in, when you twist it around, it'll actually add a small chamfer to the inside of the pipe so it will fit over the fitting easier. One of the things I figured out while putting this long run across the ceiling is that even though you put a bend in this, it kind of wants to go back to how it was, which makes it really difficult to hang. So I've used some zip ties to hold it against the clips until I can get the whole thing in place. I don't think they'll need to stay there, but either way, it doesn't matter. So I've got the end on here, and it's going to be mounted up here to the ceiling so I can put a hose reel next to it so that I can pull down a hose and use it pretty much anywhere in the shop. The system is finally in place, and I did a pressure test and found a couple of leaks, but they were absolutely my fault and not the fault of the system. There were just a couple of those plugs on the backside that I just kind of forgot to put thread tape on, so putting thread tape on those and making sure that everything was tight, got rid of all the leaks, the system is good to go. But I do have a couple more things I want to install before we can call this completely done. 3 of the things that I want to hang are these brackets. Now these are laser cut aluminum, but they also have a 90-degree bend in them. I got these from Send Cut Send. I made a 2-dimensional file, uploaded it to their website, and in a few days, these things showed up and they are awesome. I'm gonna get these things screwed to the wall, get all the tools in them, and then we'll do one more thing. So I made a mistake when I was designing these little things. I forgot to account for this little spring that sticks off the bottom of this air hammer, but luckily we've got some air tools so we can modify it. The last thing to install here is a simple hose reel. This is an inexpensive one from Harbor Freight, but honestly they all work the same. It's basically a spring-loaded hose. It's on a reel, and as you pull it out, it will ratchet and hold its position, and then when you want it to go back, you just pull it out a little bit more, and it'll roll itself back up. Now if you don't want to install a whole fixed air system, just get one of these, because you can install this on the wall right next to the compressor, pull it out and use it wherever you need to, and then very, very easily roll it back up and get it out of the way. I decided to hang this thing in the center of the shop from the ceiling. That way I can reach up, pull down the hose, get it to where I need, and then put it away very easily, and it's not going to be running across the floor. So let me get this thing mounted, and then we're done. I'm going to connect the hose reel to the system using this coil hose, and this is a temporary measure until I get a thicker hose. This is a small diameter hose, smaller than this and the entire system, which means we're going to be cutting down the volume of air that's moving through this thing. So eventually I'm going to replace this with a 3/8 hose to match this. And with that, the system is finished. Now I have a huge amount of body work that I need to start doing, on the Karmann Ghia, so I'm gonna wrap this one up. But I hope this video gave you some information for setting up a system in your shop, or maybe you don't need a system, maybe you just need a compressor. If that's the case, I hope this video helped you figure out which compressor is gonna work best for you and your tools in your shop. No doubt I didn't cover it all. So if you know some awesome information around air compressors or air tools that I didn't talk about, please leave it down in the comments and we can all learn together. We've got tons of other videos that you may want to check out. Most of them are build videos, but also be sure to subscribe so you don't miss anything that's coming out in the future, including lots of Karmann Ghia content. That's it for this one. Thanks for watching. We'll see you next time. Bong! Bong! Now I'm going to be attaching this thing to the system with this curvy hose. Springy hose, what do you call this? It can go like this and like this. It's Now you can wait for the.
You're there. You're almost there.
I'm almost there.